Imagine yourself seated by a window on a winter evening as delicate snowflakes drift gently downward, blanketing the world in a fine layer of pristine white. The faint glow of street lamps filters through, casting a soft haze, while you cradle a steaming cup of tea, its warmth seeping into your palms. Now allow your thoughts to wander into a more profound narrative, one concerning the very cosmos in which we exist, a cosmos that may not be the solid reality we perceive, but rather an immense, intricately designed program where everything is encoded by enigmatic rules. This tale originates from distant decades, when humanity first dared to question whether reality might be a fragile veneer concealing something far grander. At its core lies a peculiar number, a constant that has tormented the greatest scientific minds until their final moments. Let us journey back to the 1960s, a period when the world was abuzz with scientific breakthroughs. During that era, the mathematician John von Neumann, a brilliant intellect who laid the foundations for modern computing, proposed an idea that many at the time dismissed with a mere smile. He contemplated the capabilities of an advanced civilization, one that could simulate an entire universe within their computational systems. In this simulated universe, life would emerge, evolve, and its inhabitants would believe their world to be the sole reality, oblivious to the enclosing shell. Although this notion was not the direct basis for contemporary simulation hypotheses, it planted the seeds for deeper reflections. Today, as we look back, it resembles a subtle prophecy, whispering of the possibility that we, you and I, are existing within a sophisticated cosmic simulation, so refined that it is indistinguishable from authenticity. As evidence accumulates, a chilling blend of curiosity begins to infiltrate the mind. Could this universe be engineered, with us merely as characters in a vast game? Permit me to guide you further into the paradoxes that increasingly lead scientists to doubt the nature of our reality. First, consider the uncanny precision of the universe, a finesse that compels one to pause and exhale in awe. The physical constants, those fundamental numbers shaping all existence, appear tuned with exquisite perfection. Envision the universe as an enormous clock, where the gravitational constant, the mass of the proton, the rate of cosmic expansion, and the quantum interaction forces align with such exactitude that a deviation of even 1 part in a million would cause total collapse. There would be no galaxies, no stars, and certainly no life. Scientists, through investigations at institutions such as Stanford University and the John Templeton Foundation, have affirmed that this fine-tuning, this delicate adjustment is genuine. With evidence from constants like the cosmological constant, also known as the universe constant, refined to 1 part in 10 to the power of 120. Recent research in 2025, including studies from the University of British Columbia and analyses in journals like Physical Review D, suggests that this tuning might extend to evolving models of dark energy, where ultralight axion particles could influence the universe's expansion history, further emphasizing that such precision is not mere chance. It resembles a universe programmed for life, rather than life accidentally fitting the universe. Do you sense it? That mystery, as if an invisible hand has twisted the dials to craft the world we breathe in. Next, let us delve into the profound mathematical structure of the universe, where everything seems constructed from pure logical formulae. The mathematician Max Tegmark, from the Massachusetts Institute of Technology, has advanced the mathematical universe hypothesis that the universe is not merely described by mathematics, but is mathematics itself. Picture this: the electron maintains a stable charge, the speed of light remains unwavering, and all adheres strictly to laws like algorithms in a computer program. There is no true randomness, only logic and rules prevail. If the universe is a program, then the physical laws we know are merely the source code boundaries to prevent chaos, much like in a video game, where characters cannot pass through walls or soar without cause. Tegmark, in his book Our Mathematical Universe, published in 2014 and still widely debated through 2025, argues that every mathematical structure exists, and our universe is but one among them. Recent discussions in 2025, including analyses from the Santa Fe Institute and Emergent Mind Research, reinforce this by exploring how mathematical frameworks could underpin reality. Evoking a deep emotion, our existence is not haphazard, but the outcome of a grand logical system, where mathematics serves as the language of reality. Now step into the quantum realm, where matters turn bizarre enough to send a shiver down your spine, as if wandering into a hazy dream. At the microscopic level, an electron can occupy multiple positions simultaneously, existing and not existing, and linking instantaneously with another particle through entanglement, a phenomenon Albert Einstein dubbed spooky action at a distance. Yet the most unsettling aspect is the observer effect. Particles only settle into a definite state upon observation. Prior to that, they are as if unreal. This mirrors mechanisms in open-world games, where the map renders only upon approach, conserving resources. Scientists, via studies from PubMed Central and Quantum Magazine, have likened this to the simulation hypothesis, where reality is rendered only when required. Recent explorations in 2025, such as papers on undecidability in physics and its ties to the theory of everything, suggest that quantum mechanics' observer-dependent nature could indicate a simulated framework, where non-algorithmic understanding underpins reality. Imagine the whisper of wind brushing your ears at this moment. Does it exist solely because you are listening? This enigma awakens curiosity, prompting the question, are we the players, or merely data being processed? Another compelling piece of evidence adding intrigue to the narrative is the resolution of the universe, akin to pixels on a screen. In 2012, the Fermi National Accelerator Laboratory in the United States initiated the Holometer project to examine whether space fragments at the Planck scale, the smallest length, approximately 1.616 times 10 to the power of minus 35 meters. Although the final results in 2015 detected no holographic noise, the concept that space is discrete rather than continuous remains an enticing hypothesis in quantum gravity theories. Time, too, might proceed in discrete frames, like frames per second in a game, at such a high frequency that our senses perceive smoothness. Contemplate this: the world you behold may be a sequence of successive images, so fluid as to mimic reality, yet fundamentally discrete code beneath. Then there are black holes, those dark abysses devouring all. The physicist Stephen Hawking demonstrated that information entering a black hole does not vanish, but is stored as two-dimensional data on the event horizon, partially resolving the information paradox. This resembles a colossal database, where the universe logs every event without waste, even incorporating error correction mechanisms. Recent studies from Quantum Magazine in 2020 and Berkeley in 2024 extended into 2025 with papers on entanglement islands, reveal that these islands may harbor lost information. Adding layers of mystery, the universe acts as a self-repairing server, preserving balance. In 2025, further advancements in resolving the paradox through quantum extremal surfaces suggest that unitarity is maintained, with information encoded in ways that echo data preservation in simulations. And do not overlook the accelerating expansion of the universe, not decelerating, but hastening, driven by dark energy, comprising 73% of the cosmos. Surveys from the Dark Energy Spectroscopic Instrument in 2024 and 2025 indicate that dark energy might vary not remain constant, implying the universe undergoes subtle updates. The large-scale structure resembles a network of nodes, like a computer circuit board. The philosopher Nick Bostrom from the University of Oxford, in his 2003 paper still extensively cited through 2025, concludes that the probability we inhabit a simulation exceeds that of base reality. Given advanced civilizations could generate countless replicas. Updates in 2025, including Bostrom's reflections on artificial intelligence and its implications, reinforce this argument amid rapid technological progress. Who operates us? Perhaps our own descendants, running ancestor simulations to study history, or a superior civilization, where our universe is a minor project, or, most disconcertingly, no one, merely an automated system. Scientists like James Gates from the University of Maryland have discovered error-correcting code similar to Hamming codes in computing within supersymmetry equations, suggesting the universe possesses self-repair mechanisms like software. Research from Arxiv and conferences spanning 2018 to 2025 confirms this, bolstering simulation evidence, with 2025 discussions linking these codes to quantum information redundancy. Can we escape? Papers from 2023 in Seeds of Science and 2025 in Popular Mechanics propose hacking methods, such as seeking glitches in quantum phenomena. Yet delving deeper reveals turbulence, as if the universe resists exposing its backstage. Recent mathematical proofs in 2025, drawing on Gödel's incompleteness theorem from the University of British Columbia, argue that certain simulation versions are impossible due to non-algorithmic fundamentals, though other frameworks persist, with gravity potentially as a simulation clue. Now turn to the most enigmatic number, the fine structure constant, alpha, approximately 1/137.0359999084. Richard Feynman termed it a magic number, hurling chalk at the board and declaring it physics' greatest mystery. Einstein pondered it until death. Wolfgang Pauli, father of quantum mechanics, jested he would query the devil about it and perished in hospital room 137. Eerie coincidence. Discovered over a century ago via atomic spectra, alpha permeates. The electron speed in hydrogen is 1/137 times light speed. Electron repulsion ties to it. It governs electromagnetic force, determining atomic bonding into molecules, stellar fusion yielding carbon life's foundation. If alpha deviated by 4%, the universe would perish. Larger stars fail carbon production, smaller atoms disintegrate. The anthropic principle explains, the universe must be thus for us to exist and inquire. Alpha is dimensionless, pure, perhaps an extraterrestrial code. Links to Kabbalah exist. Arthur Eddington obsessed over proving it an integer, but 2020 measurements from Quanta show decimals. Some 2024 Arxiv studies suggest alpha varied temporally, from 1/127 post-Big Bang to now, heightening mystery. In 2025, new theories from the Santa Fe Institute and derivations via geometry in emergent research propose alpha arises from quantum granularity, unifying it with biological interactions. From 2023 to 2025, novel theories like those from the Santa Fe Institute and University of British Columbia apply Gödel's theorem to refute some simulation variants, yet the idea endures. With suggestions gravity is a glitch or quantum hacks possible. James Gates extrapolates these codes prove the universe program-like. Tegmark expands. The universe encompasses all existent mathematics. Bostrom updates. If civilizations craft simulations, we likely inhabit one. Hawking's paradox resolves via islands, implying information coded as data. Are you truly free, or every choice a branch command? If seeking escape, it is not abandoning the world, but the world acknowledging you. Are you prepared to dwell in this universe, where eternal doubt transforms everything? Finally, I extend sincere gratitude and profound respect to all the scientists, researchers, and collectives mentioned in this narrative, from John von Neumann with his pioneering vision of self-replication, Max Tegmark with his inspiring mathematical universe hypothesis, Stephen Hawking with his discoveries on black holes and the information paradox, Nick Bostrom with his seismic simulation argument, James Gates with his findings of error-correcting codes in supersymmetry, Richard Feynman with his fervent passion for the magic number, Albert Einstein with his grand legacy in relativity, Wolfgang Pauli with his foundational contributions to quantum mechanics, Arthur Eddington with his quest for mathematical perfection, and the teams at Fermi Laboratory, the dark energy spectroscopic instrument, along with countless other scientists from Stanford, the Massachusetts Institute of Technology, Oxford, and global institutions. You have devoted your lives, with persistent effort and quiet dedication, to unraveling the universe's mysteries, bestowing invaluable knowledge upon humanity and society. Without your sacrifices, our world would be far dimmer. Thank you from the depths of my heart.